Morning. So, hopefully it will be recording in a second. So I just want to set the scene. This is our very last lesson. This is covering the final piece on the scheme of work. And we are going to be looking at direct proportion, which is easy. You've done that lots of times, really, versus inverse proportion. So we've got direct proportion and inverse proportion. Now, I'm keen that we do both of these at once because half the skill is not muddling the two up. So the homework for this lesson will be a Dr. Frost, because I've been able to just pick out some questions to muddle the two up. If I'd gone down the Hegarty route, you've got a whole task on direct proportion, then a whole task of inverse proportion, which sort of takes the thinking out of it. So that's why today we've got a Dr. Frost exercise for the homework. Tomorrow I will issue you with a list of topics that you're going to be tested on when we get back from the summer break. Not straight away, so don't panic. There's no holiday work to do as such. Mr. Smith is keen that you're not set holiday work as such unless you sort of got behind. So we will have a week or two back before you have this test, and it's only covering the topics we've really covered during lockdown. And because Mrs. Miskin and I were quite keen that the test was the same for sets 1 and 2, not for set movement reasons. There's going to be no set movements. That's definitely not going to happen. It's just quite nice just to be able to compare and contrast. Now, they've gone at a slightly slower pace than we've got, so don't be surprised if there are a few topics that we've covered during lockdown that are not on the list of topics. So really, the list of topics I will be giving you tomorrow is the topics that they've done. Okay, so so you'll be getting that. They might be getting that today, but I'm giving that to you tomorrow. I then thought, given we will have finished today, that what might be quite fun would be to have an actual go at a proper real-life GCSE paper, just to see where you are at. Now, clearly, there'll be some topics you can't do yet because we haven't covered them, but I just think as we sort of wind down a bit, I don't want to just go fun lessons straight away because that's just going to be boring for you. But if you've actually got a paper to work through, that would be quite satisfying you to see what grade you could actually get now if you were to take your GCSE. And what is great is that I can actually load a paper up on real live paper, real past paper on Dr. Frost, and it just breaks the 20 questions down that would be in a GCSE paper to about 50 sub questions. So 1A will be the first question, and 1B, then 1C, and so on. So that's what I'm minded to do at the moment. But anyway, we've got to get this final topic out of the way. So without further ado, let's crack on. So direct proportion. Now, this is pretty straightforward, okay? And you've come across this in many times over the years, okay? So direct proportion, this is just literally as one variable goes up, the other one goes up accordingly. So if you're paid £10 an hour and you work 2 hours, you get 20 quid. If you work 5 hours, you get £50. So this is very straightforward. Now, I am keen, though, that you get into a sort of a 3-step logical process so you don't get into a muddle. This 3-step process will work well when we look at the inverse proportion. So I'm very keen that you don't have to be writing this down each time, but this is your thought process. So you start off by getting a provisional formula, which includes what we call lowercase k, which is an unknown constant. They will then give you some information to enable you to move from a provisional formula to a final formula. And then more often than not, they'll ask you to go and use that formula to work something out. So that's very much the process we're going to be doing. Now, my first slide, we're just going to focus on getting this provisional formula sorted. So on the next slide, I'm just going to model just doing this step 1. Okay, it's not difficult, but I think if you just see a few, you'll see what I'm getting at. So if we are told that A is directly proportional to B, you just simply start off by saying A equals K times B. Okay, so this is, again, just think back to getting paid £10 an hour, then K would be 10. So if B is the number of hours you work, times it by 10, then A would be the amount of money you get. So if A is directly proportional to B, it is A equals K times B. If C is directly proportional to the square of D, then C equals K times D squared. Okay, if E is proportional to F cubed, then E equals some unknown constant, but times F cubed. And if G is proportional to the square root of H, then step 1, G equals some unknown constant multiplied by the square root of H. So you've just got to go and process the sentence into a provisional formula. Now it's a provisional formula because you don't yet know what K is. Okay, but if it's directly proportional, and it will either say that it's directly proportional or it will be no reference at all to it being directly proportional. But if it just says proportional, proportional means directly proportional. The one we will move on to will always make it clear that it's inversely proportional. But if the question says directly proportional or proportional, they mean the same thing. So there are your step 1. So let's just go and model a few complete questions. So we are told that T is directly proportional to M. So our provisional formula is T equals K times M. Okay, now step 2, they're going to give you some information that allows you to work out what your constant is. And that's obviously that bit there. So step 2, they tell us when T is 20, M is 4. So clearly from that, we can see that K must be 4. So that was our provisional formula. I quite often just put it into a dotted rectangle to make it clear in my mind. But my final formula, because I've just worked out from that that K is 5, okay, 5 4s are 20, my new improved final formula is T equals 5 lots of M. And then often they will then ask you to go and work something out. So we are being asked to work out T when M is 3. So clearly T is going to be 5 times 3 equals 15. Now that's absolutely straightforward. You know, you could do that without using this formula business, and you could have easily just done that in sort of year 1, first one. Right, question 2. T is directly proportional to x squared. So your provisional formula, T equals K x squared. Now, they will give you some information to allow you to work out what K is. So they're telling us some facts, okay? It's like freezing time. They're giving us one bit of information. They are telling us when T is 36, X equals 3. Okay. So 36 equals K times 9. So K obviously equals 4. So our new improved formula is T equals, because we now know what K is, T equals 4 lots of x squared. So there, we've got a formula, and the question may go on then to ask us to work something out using that formula. And indeed, this question does. It's asking us to work out T when x is 5. So T equals 4 lots of 5 squared. So remembering your bid mass, that's 4 times 25, which is 100. But so the key bit is the 3-step process: provisional formula, final formula, and you may have a step 3, go and use the formula. Final one. Okay, now we're told, I don't think they would say varies directly. That's a bad choice of wording by me. It's either going to say is directly proportional to, is proportional to, but this means the same thing. So our provisional formula, E equals K times the square root of C. They will give you information to allow you to work out the unknown constant. So we're told when E is 40, that equals K times the square root of 25. So clearly 40 equals K times 5. So clearly K equals 8. So our new improved formula is E equals, not K, because we now know that unknown constant, that is 8 times root C. So there is our formula. And then finally, they're giving us a question to answer. Find E when C is 49. So E equals 8 times the square root of whatever C is. So E equals 8 times 7, which equals 56. So straightforward stuff. Now, The other thing you can be asked is when you've got a question where there is inverse proportion. Okay, inverse proportion. So this is where the relationship between the two variables is such that the variable is directly proportional to the reciprocal of the other. Okay, as one goes up, the other goes down. So a classic example is like the number of fire exits in a hotel versus how long it takes to evacuate the hotel. All right, the more fire exits, the shorter the period of time to evacuate the hotel. Okay, and not that any of the questions do this. You tend to, if you were to plot this sort of graph, it tends to look like that. Okay, with direct proportion, the ones we did before are clearly just straight line like that. These are like this. Okay, so if we are told that, so the difference is when you go and do work out your provisional formula, it's now going to be k divided by whatever, not k multiplied by whatever. So whenever a question says there is an inverse proportion relationship, sometimes they call it inverse variation, but inverse proportion, okay, one goes up as the other goes down, so your provisional formula is going to be k divided by whatever they tell you. So let's just have a look at a few questions. So example 1, m is inversely proportional to r. So your provisional formula, m equals k over r. Inversely proportional, so k over r. Step 2, so similar process, that you can now work out what k is. If m is 9 when r is 4, so m is 9 when r is 4. We are given that fact. Multiply both sides by 4, we can see that k equals 36. So our new improved formula is m equals, well, we've worked out the unknown constant k to be 36, so it's 36 over r. That is our new improved formula. And then they're asking us to use it. Work out m when r is 2. So m equals 36 over 2, which is 18. And sometimes it might be the other way around. Work out r when m is 3. So 36 divided by what gives you 3? R must equal 12. Okay, another example. No, that's the same one, isn't it? Don't need to do that twice. Okay. Right, don't model. Yes, this one is just exactly the same similar one. So I'm just going to leave that one, guys, because it is just in case you were struggling, you can play the video back and pause it at this point. It's going to be exactly the same process, and those would be the answers. Okay, now it says don't model this one. The answer's on the next slide, but I think I am going to model one more. Okay, so W is inversely proportional to the square root of T. So your provisional formula is going to be W equals, now because it's inversely proportional, it's going to be K over something. And on this occasion, they're telling us it's the square root of T. So there's your provisional formula. Where's the information allowing you to work out K? There it is. So we're told that when W is 6, T is 16. Okay, so obviously the square root of 16 is 4. So 6 equals K over 4. Multiplying both sides by 4, we can see that K is 24. So our new improved formula is W equals 24 over the square root of T. So they can then ask you to work stuff out. Work out W when T is 25. So W equals 24 over the square root of 25, which equals 24 over 5, which is 48 over 10, which is 4.8. Okay, work out T when W is 2.4. So 2.4 equals 24 over root T. Just going to speed these things up. That denominator is going to have to be in total 10, isn't it? Because 24 divided by 10 is 2.4. So T must be 100. because the square root of 100 is 10. 24 divided by 10 is 2.4. So I did, after all, model that one. Okay, and then I won't do the last one. None of them come up like this on your Dr. Frost, but people were getting a bit psyched out when a question like this came up. This proportional sign can be used, but you just really translate that into saying, okay, so y equals a constant times 1 over x squared. Or in other words, y equals k over x squared. And then people were getting psyched out about, oh, but they haven't given you a pair of values. Well, they have, haven't they? They've given you a pair of values there. When x is 10, y is 1. Okay, so that then allowed you to process that. So if you wanted to have a look at that one, that's your answer. But as I said, there aren't any like that coming up on your Dr. Frost exercise. So what I would like you to do, I think you've all pretty much been able to access the Dr. Frost. Please, can you go and work through the Dr. Frost questions? I've deliberately muddled them up. Okay, so read them carefully. Is it a direct proportional one or is it an inverse proportional one? So that's it, folks. Anyone got any questions about what we've just done, or the fact that tomorrow we're just going to just move on? Well, it's sort of revision, isn't it? But I'm trying to make it sort of fun revision, rather than just specifically work through the topics we've done since lockdown. I just thought, well, why don't we just broaden it out a bit and just have a look at a past paper and see where we're at. Anyone got any questions? No? Okay, guys. Well, go and have a go at the Dr. Frost. I will be keeping an eye out, and if you're going wrong, I will try and send you messages through to help you.
Bye. Thank you.
Okay, cheers, guys. Bye. Good luck.
So, do you know when we break up from school?
Yeah. It's next Thursday is like a virtual open day. So the last, and in theory, you're getting taught normal lessons Monday, Tuesday, Wednesday next week. Then Thursday, you're supposed to be watching sort of open day on your laptop.
Okay, thank you.
Okay, cheers, guys. Bye.
Cheers, bye.
Bye.